Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on part 2 of a 3-part series on trigonometric functions for mathematics grade 10, and that is the cosine graph. Part 1 was on the sine graph, and part 3 is going to be on the tangent graph. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on new videos we upload in the future. And if you have a question or would like to make a video request, please comment down below with the topic and grade you'd like me to cover, or alternatively send all that information to the contact details provided in the description box. Now back to the video. In detail, we're going to look at 1. Functions of the form y equals to cos theta, which is the most basic standard format of a cosine graph. Number 2, we're going to look at functions of the form y equals to a cos theta plus q, and we're going to look at in detail the effect of a and q on the graph. This is basically a shifted graph, and we'll see exactly how the shifting occurs. Number 3, we're going to look at the characteristics of a cosine graph. What is the domain, the range, what is the period, what are the intercepts, and what is the turning point. Number 4, we're going to look at examples that help illustrate how you solve different types of problems where the cosine graph is concerned. Number 5, we're going to look at a comparison between the sine graph and the cosine graph. There is a special relationship between the two. Notice even the wording. Cosine is the co-function of sine. That is why they two have a very special relationship, and you will see exactly how special that relationship is and how to use graphs to analyze that relationship. We have a lot to cover, so let's start. Let's look at the functions of the form y equals to cos theta, which is the most standard basic. It's not shifted in any way, shape, or form. It's not squashed. It's not blown up. Nothing has been done here. This is the most basic you'll ever get. Now take out a calculator and make sure that it is on degrees, DEG, and not radians or gradients, because you will get the correct answer but for a different setup altogether. So go cos, and then you punch 0, and then close bracket. That is equal to 1. That's what you get. Next, punch cos of 30. Cos of 30, close bracket, that is equals to, it will give you the square root of 3 over 2, which when you press the S to D button gives you 0.866660254, blah blah blah, which is, when you round off correct to decimals, gives you 0.87. Next, cos of 60. Cos of 60, that is equals to 1 over 2, or 0.5 if you want to write all your answers in decimal format. So it is easier for you to plot the graph. Go ahead and do that. And then number 4, cos of 90 degrees. Cos of 90 degrees will give you 0, and so on and so forth. Continue with all these, punching them into the, notice that they all have an interval of 30 degrees. So this is 30 degrees more than the previous one. That is 30 degrees more than. So I did all of this in increments of 30 degrees, so it's easier to analyze. Now, after plotting these on a set of axes, this is the type of graph you will get. How do we plot that? Okay, at 0, cos of 0 is 1, so you plot that. You go at 0, the y value is 1, or the y coordinate, so that's where you plot. At x equals to 30 degrees, the answer is on x equals to 30 degrees, that is 0.87. 0.87, 0.8 is over here, 2, 4, 6, 8, okay. 0.8.85 or 0.8, okay, it should be somewhere there. Okay, so on 30 degrees, that's where it should be. All right, well, let's plot it there. At 60 degrees, that is half. Okay, 60 degrees, cos of 60 degrees equals to half. So we go 60 degrees, half, that is 0.6, that is 0.4, so 0.5 half is there. So let's plot that. That is half. Let me shift it. That is half. And then next, at 90 degrees, it is 0. It is 0. And then at 120 degrees, at 120 degrees, it is negative half. So negative half is over here. Okay. Then next, at 150, that is equal to negative 0.87. That is negative 0.87. That should be somewhere over here. Okay. So that is negative 150. That should be somewhere here. It should be somewhere there. And then for 180, it's at a minimum. 180, that is at negative 1. So let's plot that negative 1. 180, negative 1. And then 210. 210, that gives us negative 0.87. Negative 0.87, that should be somewhere there. Okay, it mirrors this other one. Okay, next one. 240, that is negative half. Negative half is over here. This is negative 4. Negative 0.4, negative 0.5 is over there. So we plot it there. All right, next, 270. At 270, that is 0. That is 0. And then at 300, that is half. 0.5 and the half. 300, the half is up there. So there is the half. And then 330. 330, that is 0.87. 0.87, so 0.87 is somewhere up there. Okay, 0.87 is somewhere up there. And then the last one is 360 at 1. And that is how you plot the basic standard graph of a cosine graph, which is y equals to cos of theta. Now let's connect the dots. Okay, let's connect the dots. Okay, and that is how you plot the graph of y equals to cos theta. Let's remove that and put it over here. Okay, right, and this is what it should look like. Now let's look at the characteristics of that. So that's exactly what it should look like. So here, the domain, there is no point on the theta axis or the x-axis where your theta is not valid. So your domain is between 0 and 360 degrees. Your range, that is all possible y values in this whole thing. So the minimum is at negative 1 and the maximum is at 1 throughout the whole function, the whole graph. So your range is between negative 1 and 1. That is the range of your possible y values. Now for the period is how many degrees it takes for one complete cycle to be fulfilled. So from the beginning, that is half of a maximum turning point. You go up, that's 90 degrees. Go down to a minimum turning point of 180 degrees. Go back to 0 at 270 degrees. And go back to your maximum turning point, the other half at 360 degrees. That is a complete cycle. So you will have two pieces of a maximum turning point and one minimum turning point at the bottom. That's negative 1. And then the amplitude tells you the distance from the point of rest, in other words, at the x-axis when it is not shifted in any direction, to either the maximum turning point or the minimum turning point. Does not matter whether the sign is negative, your amplitude is basically will be equal to the absolute value of 1 or just 1. So the absolute value of 1. Whenever you have an absolute value sign outside a number, even if it is negative, it becomes positive. So that will be equal to 1. So the amplitude is basically, in general, the absolute value of A, and you will see exactly what A is and how it comes into play in that. The maximum turning points are two. The first one is at 0 degrees and 1. That's the point. And the second one is at 360 degrees and 1. Those are your maximum turning points. The minimum turning point is at 1 point, and that point is 180 degrees minus 1. The x-intercepts are at 90 degrees 0 and 270 degrees 0. Those are the coordinates of the x-intercepts, because the x-intercepts are where your graph cuts the x-axis. It will count the x-axis at the point where your y is 0. Now for the y-intercept, that's where the graph cuts the y-axis. There is the y-intercept. It's at the point 0 degrees and 1. And these are the characteristics of your basic standard graph of y equals to cos of theta. Now let's look at functions of the form y equals to a cos theta plus q. This one is a shifted version of the standard format. We're no longer dealing with the basics. We're now dealing with some complications. What are the complications? Let's take it step by step. What is the effect of q on the graph when we have it on the standard form? And it is a y equals to a cos theta plus. What is the effect of q? Even on algebraic functions, the effect of q is still the same here on trigonometric functions, and it tells you the shift either to the top, up, or down. If your q is positive, then your shift will be up. If your q is negative, then your shift will be down by q units. So for example, let's start from the standard format where it is not shifted in any direction, and this is the standard format where it was cos theta. You will have a maximum turning point at the beginning at 0, and you will have your x-intercept at 90 degrees, and then your minimum turning point at 180 degrees and negative 1, and x-intercept at 270 again, and your maximum turning point at 360 degrees and 1. Notice that everything is aligned with the x-axis. There is no shift either up or down, so the x-axis where y is equal to 0 is where you've got your line of rest. Your q is equals to 0 in this particular equation, y equals to cos theta, because there is no plus anything. That means it is plus 0, so it is right here on the x-axis. Now, what happens when your q is equals to 1? When your q is equals to 1, this is what the blue graph now gets. Everything is shifted 1 unit up. Look, this maximum turning point from the beginning is shifted only 1 unit up, so it lands at 2. Everything, the x-intercept at 90 degrees is shifted 1 unit up. Everything is shifted 1 unit up. The minimum turning point also 1 unit up, and it ends up now making up a x-intercept at 180 degrees and 0. That's the effect of shifting the graph of y equals to cos theta by 1 unit up, which is making q equals to 1. Everything is shifted 1 unit up. All right, now let's look at what happens when your q is equals to 3. Y equals to cos theta plus 3. So basically all you did, you get the purple graph. All what happened is that you simply took the red graph, which is the standard graph, and shifted it 3 units up. So you go, for the first maximum turning point, you went 1, 2, 3, and that's why your maximum turning point landed at 0 degrees and 4. Same for every point. You took this x-intercept and shifted it 3 units up, so that's 1, 2, 3, and that's where it lands. Same thing for the maximum, the minimum turning point. You shifted it 3 units up, 1, 2, 3, and that's where it lands. Every point has been shifted 3 units up, 1, 2, 3, and the maximum turning point at the end is shifted 1, 2, 3 units up. So basically that's how you manage to figure out what a shifted graph is going to look like, especially when it is shifted along the y-axis, up or down. Now, what happens when your Q is negative 1? When your Q is negative 1, remember we said when Q is negative, that means you're shifting it down. So when your Q is negative 1, that means it was shifted down. The negative tells you the direction down, and the 1 tells you how many units it was shifted by. It was shifted by 1 unit. In which direction? Down, because it is negative 1. So everything from the red graph has been, every point on the red graph has been now shifted 1 unit down. So from the maximum turning point, which was at 0 degrees 1, when we shifted 1 unit down, it lands at the origin, 0, 0. Same thing for this x-intercept. It lands on this point, 90 degrees and negative 1. The minimum turning point went from 180 degrees and negative 1 and went to 180 degrees negative 2. That also was shifted 1 unit down. There it lands. Notice that that also shifts your line of reference. So what we did, basically, when you shift your graph top to bottom by whatever units, you're basically shifting your graph from the standard x-axis resting point to whatever Q units down or up, depending on the direction and the number of units. So for example, for y equals to cos of theta minus 1, we shifted the resting point from the red graph, which is the x-axis, and we shifted it 1 unit down, and this is where it lands. This is where the resting point now lands. So the resting point will follow the Q. Let's make it green so that you can see. It is the resting point of the green graph. All of these graphs have got their resting points. The black graph was shifted 2 units down from the original position of the y equals to cos theta. So 2 units down. The maximum turning point was 0 degrees and 1. So that will be shifted 2 units down. It becomes 1, 2. It lands at 0 degrees negative 1. And the resting point of this graph, the black graph, was taken down 2 units from the x-axis resting point. So when we count 1, 2, this is where the resting point of the black graph is going to land. Now let me show you the resting graph of the black graph. That is where it lands, and that is what it looks like. It helps you figure out what the other characteristics may be very simply. Look, now you can easily figure out that, okay, this is now a whole complete cycle, and this is the resting point. So I must consider that resting point and make sure that I won't run away from that resting point. Same can be done with the other ones. You can have the resting point of the blue graph over here because it was shifted 1 unit up, so you go from the x-axis, shifted 1 unit up, and that will be the resting point of the blue graph. Let me shift it there so you can see. So that is the resting point of the blue graph. Let's make it blue. And the resting point of the purple graph, the Q is 3, so it means it was shifted 3 units up from the x-axis. So we count 3 units up, 1, 2, 3, and that is where the resting point of the purple graph left is now moved to. And that is how you figure out where the resting point is going to be. So that is as easy as it is. Q tells you the shift up and down, and the number tells you by how many units. So if it's negative, you shift it down by Q units. If it's positive, you shift it up by Q units. Now let's look at the effect of A. The effect of A is basically such that your A determines the shape of the graph. Now let's take it from the standard graph. Your A over here is equals to 1 because your A is the coefficient of the whole function of cos of theta. All right, so it is 1 over here, meaning that now your amplitude or the maximum point from the resting point is 1 unit. There it is, 1 unit. From the resting point to the minimum turning point is also 1 unit. Does not matter the direction. It lands you at -1, but the distance is the absolute value of -1, which remains 1, so on and so forth. So A basically tells you what the amplitude is going to be. It affects the amplitude. So if it's positive, you're going to have your normal shape that starts from the maximum turning point at 0, goes to minimum turning point at 180 degrees, and then goes back to maximum turning point at 360 degrees. However, when your A is negative, for example, in this green graph, y equals to negative cos theta, your A is negative 1. What happens is that you basically flip the red graph upside down and it becomes the blue graph. So instead of starting with a maximum turning point, it will start with a minimum turning point. The intercepts are still the same. And then instead of a minimum turning point over here at 180 degrees, it will have a maximum turning point, and vice versa. The points of intersection with the x-axis, the x-intercepts, in other words, are still exactly the same. It's just that the graph now is flipped upside down because of the negative sign. Now, what happens when your A is a multiple of 1, in other words, 2 or 3 or whatever the case may be? That means that now your amplitude has been multiplied by that factor of A. So if your A is equals to 2, that means your amplitude now will become 2. Now, if your A is a negative multiple, like for example in the black graph, it's negative 3 cos theta, that means your amplitude will still be 3, because how you calculate the amplitude is the absolute value of. So the amplitude is the absolute value of, let me change that. Amplitude is the absolute value, is equals to the absolute value of the coefficient of cos x, which is A. So whether your A is positive or negative, the amplitude will become positive, because the absolute value makes anything positive, even if it's negative. So the amplitude of the graph of y equals to minus 3 cos theta is simply equals to A equals to the absolute value of negative 3, which is positive 3. That is the amplitude of the black graph. Now, the minus sign means it is flipped upside down. So instead of starting with a maximum turning point, it will start with a minimum turning point. The point of intersection with the x-axis will still remain the same, but the turning points switch places. The maximum turning points become the minimum turning point, and vice versa. So what you have here is that you will have a maximum turning point at 180 degrees, but with 3 as your y coordinate, because the amplitude is 3. So it has been blown up by 3 times, and it has been flipped upside down because now your A is also negative. And that's how the A affects your graph. Now let's look at how the characteristics now are affected. We're looking at the characteristics of the graph of the standard form y equals to a cos theta plus p. The domain is between 0 and 360 degrees, unless you're told there is no restrictions. The range will be determined by A, basically. If your A is positive, your range will start from the negative and end at the positive, or follow that direction. In other words, your range will be negative A plus Q and A plus Q. For example, when your amplitude in this case is negative, is positive 2, the range will start from negative 2 plus Q. It was a negative 2 plus your Q is 0, so it will be negative 2, and then the other end will be A plus Q, which is basically just Q or 2. So depending on your A and Q, don't worry about this if you don't understand. We're going to use numbers so that you have this clear in your mind and you understand exactly how. The period is 360 degrees because it takes 360 degrees to complete a full cycle. That's what the period means. How many degrees do you need to have a complete cycle? It's 360 degrees, so that is the period. The intercept, the y-intercept, to find the y-intercept, just like with any algebraic graphs, To find the y-intercept, you make x 0. In this case, you will make theta 0 and solve. Now, to find the x-intercept, same story, you will make y 0 and solve. Now, let's look at some examples. Example 1 says sketch the graph of f of theta is equals to 2 cos theta plus 3, for theta is an element of 0 degrees to 360 degrees. In other words, your domain is between 0 and 360 degrees. Now, how do we do this? There is a simple way we can use to figure out what it's going to be without using any methods to spot. If you want to use calculations, this is how you do it. Remember, for the standard y equals to cos theta graph, these are your milestones. These are your important points. The first one is the first maximum turning point, maximum turning point 1. Maximum turning point 1. This is at the point of 0 degrees, and the y-intercept is 1. I mean the y-intercept, yes, is 1. That's the first maximum turning point. And then the next thing that comes is your x-intercept. The first x-intercept will be at 90 degrees and 0. And then the next thing that comes is the minimum turning point. Minimum turning point will be at 180 degrees and negative 1. And then you have another x-intercept, and that will be at 270 degrees, 0. And then the last thing is the second maximum turning point. The second maximum turning point will be at 360 degrees and 1. In other words, this is what the standard graph of a cosine graph looks like. So the last one is your 360 degrees, and that is your 0 degrees. That's the first maximum turning point. That is 180. No, so that is 90 degrees, 180, 270, and 360 degrees. You should have this picture in your mind. If you don't, quickly jot it down in a pencil, draw it in a pencil, so it keeps you focused and you are able to follow this pattern in order to figure out what those points for this particular graph that is shifted. Notice that your A is 2 and your Q is equals to 3. All right. Now let's go ahead. Let's calculate. For the first one, the first maximum turning point, we substitute our theta is 0 for 0. Okay, so we find f of 0, that is equals to 2 cos 0 degrees plus 3. Okay, when you take out a calculator, that should give you 2 times cos of 0 plus 3, and that is equals to 5. So that's what you get there. That is equals to 5. Next point is the x-intercept, the first x-intercept. Okay, the x-intercept for the standard graph is at 90 degrees and 0. Okay, so what you do is you substitute your 90 degrees for the x-intercept in this one. So we find f of 90 degrees. That is equals to 2 cos 90 degrees plus 3. Take out a calculator, that will give you 2 cos of 90 degrees plus 3. That gives you 3. So that will be equals to 3. Okay, that is equal to 3. Next, the minimum turning point. The minimum turning point, minimum TP. For the standard cosine graph, that is at 180 degrees. So that should be at 180 degrees and negative 1. That is for the standard graph. All right, so we substitute for f of 180 degrees. So that is equals to 2 cos of 180 degrees plus 3. Okay, which is equals to, take out a calculator, 2 times cos of 180, those brackets, plus 3. And that gives you 1. And then we've got another x-intercept. In the normal standard graph, the next x-intercept will be at 270 degrees. 0. Obviously, x-intercepts are on the x-axis, so the y-coordinate is 0. So we substitute that. We go therefore f of 270 degrees equals to 2 cos of 270 plus 3, which is equals to, take out a calculator, 2 times cos of 306 of 270. 2 cos 270 plus 3, and that is equals to 3. And then the last one is the maximum turning point. The last one is the maximum turning point. Let's get the maximum turning point. All right. Okay, let me use this bit to calculate maximum turning point. Maximum TP, the second one, is at 360 degrees. So what we do is we find f of 360 degrees. Okay, f of 360 degrees will be equals to 2 cos of 360 degrees plus 3. Okay, let's calculate that. So that is equals to 2 times cos of 360 degrees plus 3. And that gives us 5. So the last part, which is the maximum turning point, is equals to 5. That is the maximum turning point 2. All right. Now let's plot these points on a graph paper on the set of x's. But before we do that, we will be plotting the standard equation of the graph. So let's first start with the standard format at 0. At x equals to 0, I'm going to make that the red graph. So at x equals to 0, theta is equals to 0, you have y for the standard one. So we're plotting y equals to cos theta here. Okay, let me fix that. The red one we're plotting is y equals to cos of theta. All right, that's the standard one. Okay, at 0, that is 1. That is a maximum turning point. At 90 degrees, that is 0. At 180, it's negative 1. At 270, it's 0 again. At 360, it's 1. So this is the pattern that it follows. Let's join the dots. This is the graph. And now we plot the purple graph, which is y equals to 2 cos theta plus 3. Okay, according to this one, at 0 degrees, this is the y coordinate. That is equals to 5. It's equals to 5. So at 0 is equals to 5, and that's where we plot the point. At 90 degrees, it is 3. At 90 degrees, it is 3. So 90 degrees, it is 3. And then at 180 degrees, it is 1. 180 degrees, it is 1. That is the point. And then at 270 degrees, it is 3. 270 degrees, it is 3. So where is 3? There is 3. 270 degrees, it is 3. There. Then at 360 degrees, it goes back to 5. It goes back to 5, so we'll plot there. It goes back to 5. Now we join the points. Let's join the points. Okay, but before we join the points, notice that this one was shifted 3 units up. All right. So the standard resting place, which is the x-axis, was shifted 1 to 3 units up. So we draw a line of rest there to give us some guidance when we connect the dots. You don't have to do that, it just helps with keeping things in context, so you're able to. And that is how the graph looks. That is the graph of y equals to 2 cos theta plus 3. That is the purple one, and then the red one is the graph of y equals to cos theta. That is the standard graph of cos theta, and this is what it looks like when using a graph calculator. And that's exactly perfect. Now let's look at example 2. Using your knowledge of the effects of A and Q, sketch each of the following graphs without using a table of values for theta is between 0 degrees and 360 degrees. So now we're using our knowledge and understanding of A and Q. So we're not going to be plotting points on a table. What we're going to do is we're going to draw the standard equation of y equals to cos theta and then take it from there. Use that to reflect on the -2 and the q equals to 1. So the standard format of that, okay, let's take it back to red. Okay, so we're going to plot y equals to cos theta, the standard one. Okay, that's the first one we're going to plot, so it gives us some direction. So at 0 degrees, that is equals to 1. Okay, at 0 degrees, it is 1. At 90 degrees, it is 0. At 180, it's -1. Here is -1. And at 270, it goes back to 0. At 360, it goes up to 1. And that is how the graph of y equals to cos theta should look like. Let's connect the dots. Let's join the dots. All right. That's how we join the dots. Now, let's use our knowledge of A and Q and their effect on the graph of the form y equals to A cos theta plus Q to now figure out what this y equals to -2 cos theta plus 1 is going to end up like. First of all, Q equals to 1, +1, meaning that our standard place of rest on the x-axis has been shifted 1 unit up. So that's the first thing we must do. So let's make that okay, so let's get the resting points sorted. Let's make that a blue graph. Okay, let's make that a blue graph. So I'm going to turn everything into blue now. All right, now that is the standard place of rest. Now notice our A is equals to -2. Our A equals to -2. Our Q equals to 1 here. So we've managed to figure that one out. We've moved the standard place of resting. And then now our A is equals to -2. That means the amplitude is equals to the absolute value of -2, which is equals to 2. So meaning that it was stretched by a factor of 2. So the whole graph will be 2 times the amplitude of the first one. So, and it is negative. Our A is negative, meaning that we now flip it upside down. So instead of starting with a maximum turning point, we'll start with a minimum turning point. Originally, the minimum turning point was supposed to start at -2, but it has been shifted 1 unit up, so it will start at -1. There, let's make that blue to start at -1 because it has shifted up. Now at -1, we must make sure that the resting place is maintained, number 1, and number 2. Now at the point where it was supposed to have a x-intercept at 90 degrees, it's going to have been shifted by 1. So it's at the resting place. There is the resting point. So we'll put that there. Okay, the resting point there, we'll put it there. Now the next thing we plot is our maximum turning point. We're supposed to have a minimum turning point, right, at -2, right? but that has been flipped upside down, so it will be a maximum turning point at 2. There is 2, so that's the point where we will be. Alright, next we'll go back to our resting place that was supposed to be the x-intercept. So that's at 270, because the graph was stretched and then shifted 1 unit up. That's what we get. Now on the last one, we're supposed to have a maximum minimum turning point. If we're just dealing with minus 2 cos theta, there'll be a minimum turning point again at negative 2, but it was shifted 1 unit up. So we take it. Okay, let's see. This is no. Negative 1 is here. Sorry about that. Okay, this negative 1 is here. Alright. Okay, so that becomes a minimum turning point at negative 1. Now let's join the graph, the points. So this is what the points join to be. Okay, this part. And then we join this. And then the last bit is joined. And that is supposed to be the graph of y equals to minus 2 cos theta. Y equals to, alright, that is supposed to be the graph of y equals to minus 2 cos theta plus 1. Now let's look at what the graph calculator calculated, and it's exactly what we are getting. We got here. So the maximum turning point will be at 3. Let's compare that with ours. There it is at 3. There is the maximum turning point at 3. And then you'll have your resting point at x equals to 1. There is the resting point. The resting point should have been there. It will be here. Yes, that's the correct resting point at x equals to 1. That is the correct resting point. And then the minimum turning point should be at negative 1, because it was shifted 1 unit up, and there it is. And that is the correct graph. That's how you draw a graph of y equals to a cos theta plus q by inspection, using your knowledge of a and q. Now let's look at question number 3. Example 3 says the graph below shows a trigonometric equation of the following form: y equals to a cos theta plus q. 2 points are shown on the graph. Point A at 180 negative 1,5 and point B at 0 degrees and negative 0,5. Calculate the values of A, the amplitude of the graph, and Q, the vertical shift of the graph. Basically what you need here is your knowledge of solving for simultaneous equations. So the first thing is you write down the equation of the graph, the standard equation of the graph, and then you substitute these 2 points, equate the first one to equation 1, and then equate the second one to equation 2, and then take it from there. You solve the simultaneous equation. Now let's start with the standard format of the equation. The standard format of the equation is y equals to a cos theta plus q. All right, we've got point 1, point B, and the coordinates of point B are 0, negative 0,5, 0, negative 0,5, 0, negative 0,5. This point lies on y. Okay, it lies on y on the graph. All right, now therefore what we do is we substitute. Therefore, what is the y coordinate of the point that's negative 0,5? That's what we put on y. So negative 0,5, negative 0,5. That's what we substitute in place of y, equals to a cos of, we've got the theta. The theta is equal to, let's reduce this, a cos of, the theta that we substitute is the x coordinate of this point, that is 0 degrees. Okay, so that is 0 degrees, 0 degrees. All right. plus q. We don't know what q is, so we just write it as plus q. All right, now therefore negative 0,5 is equals to, now cos of 0 is equals to 1, so that will be a times 1 plus q, which then gives us negative 0,5 equals to a plus q, and that makes up your equation 1. Next, this next point, point A, and the point A is, let's see the coordinates, that's 180 degrees and minus 1,5. 180 degrees minus 1,5 lies on F as well, on Y. Therefore, we substitute. Therefore, the Y coordinate is negative 1,5, so we substitute that on the Y. So negative 1,5 is equals to, that is equals to a cos of, the angle is 180 degrees, and that's what you substitute, 180 degrees. So you substitute the 180 degrees, all right, plus q, all right, therefore negative 1,5 equals to, cos of 180 is, okay, so cos of 180, that is equals to negative 1, so we go, that is a times negative 1, that's cos of 180 plus q, and that leaves you with the equation 1, negative 1,5 is equals to negative a plus q, and that is equation 2. So that is equation 2. And now you equate these two. All right, you've got a plus q and minus a plus q. Let's add them together. All right, let's add them together. Equation 1 plus equation 2. Equation 1 plus equation 2. All right, so 1 is negative 0,5 equals to a plus q, and then the next one, 2, is negative 1,5 equals to negative a plus q. All right, since you've got a and negative a, you just add them together. The a's will eliminate each other, and you'll be left with q and the number on the left hand side. Negative 0, okay, we're adding here, very important, this is plus, okay. So negative 0,5, sorry, negative 0,5 plus negative 1,5, that is negative 0,5 plus negative 1,5, so that's negative 0,5 minus 1,5, and that gives you negative 2. So that gives you negative 2. Negative 2 on the left hand side is equals to, the a's cancel out, so you're left with 0 on the part of a, okay, plus q plus q, that is equals to 2q. So you have 2q equals to negative 2. All right, let's add a page here. Okay. Duplicate this line. All right, so you've got negative 2, therefore negative 2 equals to q. Let's take it from negative 2 equals to q, 2q equals to 2q. Okay, that is equals to 2q, and then you divide both sides by 2 to get rid of the 2 on the left hand, on the right hand side. Okay, divide both sides by 2. Okay, the q's cancel out. Okay, here we're left on the left hand side, we're left with negative 1. Therefore negative 1 equals to q, and that is your q. Your q is negative 1. So what you do is you substitute back into any of the two equations. Substitute into into, okay, let's substitute into equation 1, into 1. All right, when we substitute into equation 1, this is what we get. All right, equation 1 is negative 0,5 plus a plus q. Negative 0,5 plus a plus 2. Negative 0,5 equals to a plus q. So we substitute the q, which is negative 1. Therefore, negative 0,5 equals to a plus, and that becomes negative 1. That is negative 1 for q. All right, now you take everything to the left-hand side. Therefore, negative 0,5 plus 1, it becomes plus 1 equals to a. Negative 0,5 plus 1, or 1 minus 0,5, that is 0,5. Therefore, 0,5 equals to a. Meaning that, therefore, your equation, therefore, the equation is y equals to, your a is 0,5, so 0,5 cos of theta, and then your q is negative 1 minus 1. And that is how you find your, and that is, okay, the last bit, that is how you find your answer. The last bit is comparing the sine and the cosine graph. Remember, I said in the beginning that the cosine graph and the sine graph are co-functions of each other. Look at the names, sine, cosine. So the cosine graph, of course, is mainly simply the co-function of sine. Now, how do they compare with each other? From part 1, you've learned that the sine graph starts at 0 degrees and then peaks at 90 degrees 1, and then goes back down to another x-intercept at 180, then gets to a minimum turning point at 270 negative 1, and then goes back to 0 at 360 degrees. Now the cosine graph, on the other hand, starts differently. Starts at the maximum, goes to 0 at a peak of compared to that, and then goes to negative minimum, goes to 0, negative minimum turning point, then goes to 0 at 270 and goes back to a maximum turning point at 360 degrees. Now, basically, all this is, notice something. These two, and we'll deal with this in grade 11 even more. So basically what they've done here is shifted this graph of the red one 90 degrees to the right. And that is why this is now the resulting equation. So the cos graph is simply equals to the sine graph shifted 90 degrees to the left. But the sine graph is mainly simply equals to the cosine graph shifted 90 degrees to the right. When you have a minus, that means you're shifting to the right, 90 degrees to the right, and when you have a negative, you're shifting it 90 degrees to the left. If you don't understand this very well now, don't worry about that. We'll do this in more detail in grade 11 when you get to grade 11. We've come to the end of this video. Thank you for watching. See you in the next one. Bye.